Why lizards can grow their tails back and we can't. The science of regeneration. Hey everyone, welcome to FactSpark. Have you ever seen a lizard make the most dramatic escape of all time? It's a scene ripped right out of a Hollywood movie. A predator lunges, the lizard makes a split-second decision, and poof, the predator is left with a wiggly, writhing piece of tail while the lizard sprints off, completely unharmed. It's the ultimate magic trick, a biological superpower that many of our scaly friends have mastered. But here's the real question that keeps us up at night. How on earth do they just grow it back? Today we're diving deep into the weird, wonderful, and slightly wild science of lizard regeneration. Losing a tail isn't just a random accident for a lizard. It's a premeditated act of self-defense, what scientists call autotomy. The tail is basically a ticking time bomb with built-in fracture planes, sections designed to snap cleanly with a single quick muscle contraction. And to avoid a messy cleanup, special muscles at the break site clamp down to stop the bleeding instantly. But the best part? The severed tail doesn't just lie there. It writhes and twitches on the ground, creating a perfect living decoy that can distract a hungry predator for a full 5 minutes. Some of the younger lizards, like juvenile skinks, take this trick to the next level with tails that are a shocking, vibrant blue or pink. It's like they're saying, "Hey, look over here. Eat the bright, flashy distraction, not my head." Once the lizard makes its great escape, the real magic begins. The wound heals faster than you can say blastema, and a remarkable cluster of cells, the blastema, forms. This is basically the lizard's architectural crew, a collection of master builders that have all the genetic blueprints needed to rebuild a new tail from scratch. And this crew is full of fascinating characters. There are the radial glial cells, the stem cells that get the whole project started, and then there's an amazing partnership between two other types of tiny builders, fibroblasts and phagocytes. Think of the phagocytes as the cleanup crew, clearing out all the debris, but with a secret weapon. A specific type of phagocyte, called a septiclast, acts as a foreman, sending out signals to the fibroblasts, telling them to start constructing new cartilage. It's a perfectly coordinated, microscopic construction site, all thanks to a precise genetic program. But here's the unexpected twist. That new tail is not a perfect copy. From a distance, it might look the same, but up close, it's a total knockoff. While the original tail had a perfect row of bony vertebrae, the replacement has a single, simpler tube of cartilage. The muscles are long and less flexible, and the skin often has a different color and texture. This superpower also comes with a hidden cost. The tail is a major fat storage unit, so losing it is like losing your emergency snack stash. This can leave a young lizard's growth and immune system a little bit behind. Plus, a missing tail messes with their center of balance, turning a speedy dash into a slightly wobbly escape. So why do they bother? Because for a lizard, having a flawed tail is 1,000 times better than not having a body at all. Now, as impressive as lizards are, the animal kingdom has some serious regeneration royalty. Take a salamander, for example. If you snip off a salamander's limb, it grows back a near-perfect, fully functioning replica, complete with bone and nerves. The difference? It all comes down to their stem cells. A salamander's stem cells are like a multi-talented superhero team that can create a huge variety of new cells, while a lizard's are more like a single skill specialist. And if you think that's wild, meet the planarian flatworm. You can literally chop one of these little guys into tiny pieces, and each piece can regenerate a completely new, fully formed worm in a matter of days. They pull off this amazing feat with special neoblast cells, the ultimate jack-of-all-trades stem cells. But the real reason scientists are so obsessed with these regenerating rock stars is to learn their secrets. By studying why the lizard's regeneration is just a little bit off, researchers are figuring out how to make it perfect. In fact, scientists have already managed to help a lizard grow a perfect tail for the first time in millions of years. This research is providing a blueprint that could one day help us unlock our own regenerative potential to treat spinal cord injuries, damaged cartilage, and a whole host of other challenges. So, the next time you see a lizard lose its tail, remember that it's more than just a cool trick. It's a living, breathing key to the future of human medicine.